Welcome to Chapter 8, Hypothesis Testing. I want to start off with an example so that you can get a feel for what we do with hypothesis testing. Essentially, we take some kind of a claim or some kind of a conjecture that someone has and then use mathematics to determine whether or not it is true. So here's an example of that. And when I say true, I hesitated because it's not about being right or wrong. It's about being, are we significantly different than the stated mean or the stated amount, or are we not significantly different? Well, let me read this one and we can talk more about that. A national report states that the average amount spent on textbooks for a 4-year degree is $3,262. The Student Senate feels that seniors they know have spent more than this. They conduct a study of 50 randomly selected seniors and find that the average debt is $37.28 with a standard deviation of 997. With alpha equal 0.05, this is the significance level, we'll talk about that in a minute, is the Student Senate correct? Well, for starters, the Student Senate thinks that the average is not this number that the report states, but it thinks that the average is more than that. So they're hypothesizing that the average spent on textbooks is more than that amount that was in the claim. So they're hypothesizing that the average is more than $3,262. Well, we can write this mathematically. The average is represented by mu, is more than, that's one of our inequality symbols, greater than 3262. 3262. What we've created here is called the alternative hypothesis. Let me write that down. Alternative hypothesis. Let me keep going with the hypotheses before we continue on with the other information. Whenever we test something statistically, we're always using two hypotheses. The alternative hypothesis is actually stated second. The first hypothesis, let me put an arrow here, the first hypothesis is called the null hypothesis. The null hypothesis is along the lines of innocent until proven guilty. So with the null hypothesis, we go ahead and assume that, you know what, let's just say that the report is correct and that the average is actually 3262. So what we want to really do, though, is start with the null hypothesis, that it really is true, and we want to see if our number, the 3728, is significantly more than that. Let me put these two together. We've got the alternative hypothesis and we've got the null hypothesis. We can go ahead and state those now. And as we state these, the null hypothesis is h sub 0. And we say that h sub 0 for the null hypothesis is just this statement, mu equals 3262. The null hypothesis will always have the equal sign. In some textbooks, and actually in the previous edition of our textbook, the null hypothesis could also, I wouldn't even write this down if I were you, have any inequality that included the equals, less than or equal to, greater than or equal to. But this edition of the textbook does not include those. So every single null hypothesis has the equal sign. The second hypothesis was the alternative hypothesis. We're going to state that as h sub 1, or you'll also see h sub a. So h sub a or h sub 1, the alternative hypothesis, is typically but not always the claim. Okay, so the Student Senate thinks that the amount's more than that the average is more than 3262. These are our hypotheses. So we always have two hypotheses for each statistical test. The null hypothesis that includes the equal, and the alternative hypothesis. In this case, our alternative hypothesis has the greater than symbol. This, does yellow show up? Yep. This could be the less than symbol or the not equal symbol. So these are our inequalities that we use for the alternative hypothesis. So these are our two, we call them the two opposing hypotheses. We're going to work more on those, but I want to talk more about this example before we look at some other hypotheses. So let's keep going here. There's some other numbers that we haven't identified. We've talked about the hypotheses, significance level, and the types of errors are actually tied together. Well, I want to start by talking about our sample. So everything that we've got here in our hypotheses is based on the report. So you notice that I used a population symbol here. I used mu instead of m or x bar. So as we move into the sample mean, we are going to test the sample mean. The sample mean. Okay, so here's 3262. And what was it? 37, there it is, 3728 that we found with our group of seniors. Well, I know that that's more than 3728. I know it's more than 3262. The question is, with this greater than symbol, is it significantly more than? Is it significantly more than the 3262? That's our question. Because we know there's going to be some error. Let's see, we surveyed 50 people. Maybe we surveyed 50 students that have really expensive textbooks. Science majors, pre-med, they tend to have very, very expensive textbooks. So we want to make sure that we're not just greater than that, but that we are significantly greater. But we go ahead and we state our sample mean using an x bar, or you could use m. X bar is generic, m is specifically sample mean. That's going to be the 3728 from that group of 50 students, which gets us to our sample size. So n is equal to 50. So this is our sample mean, sample size. The size of our sample also affects whether or not that number is significant. If I were to survey, 50,000 students, then I could more easily say that, yeah, that is significantly more than. But with only 50, it's a very, very small sample size. Okay, we almost got through all the information. We talked about sample size. We talked about the sample mean. What about the significance level and the type of error? Well, we've been working a lot on confidence intervals, which included the normal curve. And this is no different. This is mu here, that 3262. This is x bar, or m. We're going to go ahead and draw this on a normal curve. So let me redraw. Our hypothesized mean goes in the middle. So mu, which is 3262, from the null hypothesis, always, so that number from the null hypothesis always goes in the center of the normal curve. So mu is 3262. And I know that 3728 is over here somewhere, but I want to know if it's significant. Remember that this total area is equal to 100% or 1. Well, as I look at that significance level, let me draw it down here. Alpha was 0.05. Well, we're going to use this 5 or 5% to draw our significance area. So I want the size of my significance area to be 0.05 or 5% of the entire area. The entire area here is 100%. I'm going to let 5 of that be the rejection region. And this is set somewhat randomly, so these are all set by the problems that you see in the textbook or in Connect Math, so they're all set up for you. So if this is 100%, I'm going to put my significance level, what would look like 5%? Maybe this much? And it always fits into a tail, so it fills in that tail. So this is 5% of the area, so this is 5%. The rest of it then would be 95%. So anything that's greater than, but not butting into the 5% region, or less than, obviously that wouldn't be more than, would be one where I would say, you know what, it is about 3262. But if I'm over here in this tiny 5% area, I am going to say, you know what, that 3728 really is significantly greater. Let me give you some language here. This region right here is called the rejection region, or the significance area. I call it the rejection region. And right here, this is the fail to reject area. And we use that language, fail to reject or reject, because we're talking about the null hypothesis. Am I rejecting that the null hypothesis is true? I landed in the 5%, or am I failing to reject that the null hypothesis is true? We're going to come back to this example. Oh, let's see. Let me make sure I finished everything off my list first before I say we're going to come back. We're going to come back and do a full hypothesis test on this. We're actually just about there because we really want to know where to put that 3728. So where does that live up here on our normal curve? But let's check our list first. So the significance level, we talked about that. The significance level is the size of the rejection region. Size of reject region. Okay, so that's the significance level. Types of errors, I said that was tied to the rejection region. So let's go ahead and put the type of errors. I had a little bit of space left at the bottom here. If this is my rejection region, that means that I'm going to reject the null hypothesis if we fall in the 5% area, which is the tail. And if I reject it, that means 3728 is bigger, significantly bigger. It's going to land over here. Not bigger because I had a small sample size or I interviewed the wrong students, but significantly bigger. It's only 5% of that area. Since I'm only rejecting 5% of the time, this leaves me with the possibility of an error. I could be wrong, and that would be called a type 1 error. So a type 1 error is alpha, and in this case it is that 0.05 or 5%. And that means that there is a 5% chance that we reject a true null hypothesis. Basically, that means that we said that 3728 was significantly bigger when it really isn't. There was some flaw, some other flaw in our testing. So that's the type 1 error. So the type 1 error is the size of the rejection region. The other error is actually beta. So the other error is beta. So beta is a type 2 error. We do not focus on beta in this class. So it's a type 2 error. It will happen if you fail to reject, fail. This is the double negative 1. You're going to fail to reject a false null hypothesis. Okay, that is a lot of information. It seems like it would be 95%, but it really isn't, and we're not going to focus, since we're not a high enough level stats course here, we're not going to focus on what that number is, but instead we're going to focus on the possibility instead. I'm going to redraw that normal curve. We had that rejection region here, reject, fail to reject. If I fall into the rejection region, we have a possible type 1 error. If we fall into, I'm going to put a line there, if we fall into the fail to reject region, so here's our mu, and the 3728 was close to mu, then we would have a possible type 2 error. We'll talk about this more as we go on, but I want you to be familiar, especially with the fact that the type 1 error is alpha. I have a 5% chance making of an error. If this was a 10% area, I'd have a 10% chance of committing that type 1 error. Okay, so now we're going to come back to this last example. We are going to conduct a full hypothesis test, but before we do, I want to give us a little bit of practice with just stating hypotheses. So I've printed off some different examples here. I'm going to switch gears. I'm going to keep this close. I'm going to switch gears here. And if you haven't already, you can print these documents that I'm working off of from the Canvas classroom. Okay, so let's take a look at this first one. We're just going to state the hypotheses. The first one, a jewelry designer claims that women have wrists with a mean of 5 centimeters across. Gosh, that's a claim there. A simple random sample of wrists of 40 women has a mean of 5.07. A sample. So I have a sample size and a sample mean. The standard deviation is 0.33. Test at the 0.05 significance level. Well, first of all, this is our alpha. Alpha is equal to 0.05, and it's the probability of a type 1 error. I did not ask you for that, but that's a little bonus there. What we really wanted to do, though, is to state our hypotheses. We know that we need a null hypothesis. That's going to have an equals in it. And we need the alternative hypothesis. The alternative hypothesis could have greater than, less than, or not equal. For the hypotheses, you need the claimed mean, or the one from the report, not the sample mean. The sample mean does not go in the hypothesis. So I'm going to pick up that 5. This is mu. The jewelry designer claims that that mean wrist size is 5. The mean is 5 centimeters. So mu is 5. Let's see, a sample says it's 5.07. Test at the 0.05 significance level. You know what's interesting about this one, it doesn't say that we took a sample because we think it's more or we think it's less. So the fact here is that it's just different. Unless it says we think it's significantly more, we don't use greater than. Unless it's specifically stated, we're going to conduct a sample because we think. But it's not. It just says, you know what? We got 5.07. Let's see if the designer's right. Well, either the designer is right or he's not right. Either it's 5 or it's not 5. That one's a little bit tricky, but it didn't state in there that it was, we thought it was greater than, or we thought it was less than. So that one is null hypothesis, equals, always equals. Alternative hypothesis, you're going to choose from these 3. Nothing was stated greater than, nothing was stated less than. We don't pay attention to the number there. That's just our sample value. And so we use not equals. Okay, let's actually do, I want to do number, let's do number 3 next. Okay, number 3. Number 3, the health of a bear population in Yellowstone National Park is monitored by periodic measurements. A sample of 54 bears, let's just get used to writing some of these down, has a mean weight. This is my sample, so that must be M, or X bar, same thing, 182.9 with a standard deviation, so that would be S, of 121.8. At the 0.05 significance level, so this is alpha, test the claim that the population mean of all such bears bear weights is greater than 150 pounds. Greater than 150 pounds. The mean is greater than 150. Well, we have to use equals in the null hypothesis. So when I put these together, I know that this mu greater than 150 has to be in the alternative hypothesis because that's where greater than, less than, or equals lives. In the null hypothesis, that's equals. So mu equals 150. Okay, let's back up and take a look at number 2. So number 2, M&Ms, a random sample of 19 green M&Ms, so n is equal to 19, has a mean of, so this would be x bar, or m. Assume that the standard population deviation is this number. Okay, this would be population, that would be sigma. Use 0.05. There are other significance levels. These all happen to be 0.05. To test the claim that the mean weight of all green M&Ms is equal to. So on this one, mu is equal to 0.8535. Well, that's a null hypothesis. That's where the equals lives. So when we put these together, this claim is the null hypothesis. Mu equals 0.8535. I'm going to label that as my claim. And H1, let's see, it doesn't say anything about we think it's greater or we think it's less than. We just think it is, which means it either is or it isn't. Remember, these are our choices for the alternative hypothesis. Nothing talked about less than, nothing talked about greater than. I don't compare the numbers. I just look at the words. So that means I choose not equal to 0.8535. Now, as you take a look, in that last sentence, it talked about a claim, but it had the word is equal to, so I used that as the null hypothesis. In number 3, we had a claim, but the claim said the mean is that the weights is greater than 150. So in the second one, the claim actually lives there. The book asks you a little bit about the claim. I don't focus on it so much. What I do focus on, so that you can be prepared, is I will ask you to interpret your results once we get to the point where we're doing a full hypothesis test. Let me go ahead and finish up that last example. So that previous example, and I'm actually going to start from the beginning, and we'll do one start to finish, and then in the next video, we'll do several of these start to finish. Okay, so I'm going to cover up or try to cover up some of this stuff. Okay, so this one says a national report states that the average amount spent on textbooks for a 4-year degree is $32.62. The Student Senate feels that seniors they know have spent more than this. So already we've got our hypotheses. So the report states that it is, the average is, so that's our null because of the equals. So average is 32.62. I use that number from the national report, not my sample, for the hypotheses, both of them. So the alternative hypothesis, HA or H sub 1, is from the second sentence. They feel that students have spent more than this. They think it's more than 32.62. We call this step 1 of the hypothesis testing. I don't necessarily go in a specific order, but always step 1 is stating your hypotheses. Step number 2. So for step number 2, I'm going to draw myself a picture. And in our picture, mu from the hypotheses always goes in the middle, 32.62. I'm going to use that significance level of alpha equals 0.05. And this is a really great trick. If you take a look at your alternative hypothesis, think of it as an arrow, and this arrow points to the tail. It's going to point me to a tail on the right. Significantly more would be over here on this side. If it was a significantly less, I would shade in this side, but this one's a significantly more. So my rejection region is more than, so over here, and I shade in an area that could be 5%. So this is my rejection region. So reject, and then all of this is fail to reject. Let's go ahead and get our test value. Okay, I'd ask you at this point if you want to do it the easy way or the hard way, but I'm hoping that you're saying easy way, and we're going to use the calculator to do the test value. So we're doing the test value next. So to do the test value, we're going to use the calculator. And I brought the two different versions of the operating system. Let me do it with mine first. They're really, really similar, but this will give you a chance to see me typing this in twice. We're going to need all of our data to do this. So let me go ahead and write down what we've got. So we've got that the mean is 3262. We have that the sample mean was 3728. We had 50 students. You can't see my finger. We interviewed 50 students, so N is equal to 50. We were given a standard deviation of 997. So the standard deviation of the seniors, that would be S, is 997. And S is approximately sigma. I need a standard deviation to use the normal curve. That tells me about significance. Because if I am 3 standard deviations away, I might still be in the fail to reject region. But if I'm 5, 6, 7, 8, 9, 10 standard deviations away, I'm probably going to be in the reject region. So that standard deviation is our significance piece. And then finally, and I wrote it there, but I'll write it again, alpha, the size of our rejection region, is 0.05. So let me go ahead and pull up my calculator here. So I've got my calculator. I'm going to go to the stat menu, so stats, over to tests. I'm just doing a z-test, and it's hard, you can't read everything, but the first tests are tests of the mean, and then when you work down further, it's a test of a proportion, which would be a percentage. So we're going to choose the first one. And am I using data? Data would be if I had my data in a list, like L1 or L2, and I don't. I have averages. So I'm going to use stats, and it says, what is your mean from the null hypothesis? The mean, oh, there it is, 3262. So that's 3262. Standard deviation, well, we only have the sample, but we're going to use that to approximate the population, so 997. X bar, that's our sample mean, so that is 3728, 3728. N is not 40, but 50. And this is your alternative hypothesis. So our alternative hypothesis is, oh, it's right there, greater than. So this would be not equals, less than, greater than. It has all 3 choices. I choose greater than, and then I hit calculate. Okay, so here's what it gives me. It says we're testing that mu is greater than. It gives me a z-score of 3.3. It gives me a p-value, which we'll talk about later in the next video. And it just is confirming that you typed in a sample mean of 3728 and a sample size of 50. Of all of this, it's nice to double check everything, but what we really care about for this example is z. In some other examples, if we're doing a p-value test, we would care about p. I'm going to grab this z off. This is what we call the test value. Okay, so the test value, z is 3.305. That tells me that 3728 is 3.305 standard deviations away from 3262. I still don't know where to put this. I know that the size of this region is 5%, but I don't know where 3 standard deviations lives, if it lives in the rejection region or not. So we've got our test value, which means that we need just one more piece, number 3. We need the critical value. To get the critical value, we're going to use, your book uses table E. I'm going to use table F because it's so nice. So I'm going to go ahead and use table F. I've got an actual textbook here, but you can print out the figures and formulas document in the online classroom. But let's see, table F is here. This is the same one that we used for confidence intervals. So we're going to go ahead and use table F. Oh, it's huge. So it gives me the confidence interval values across the top. We've used this before, but now we're going to use the one-tail or two-tail. This is a one-tail test, and alpha is 0.05. We're going to go all the way to the bottom. The values at the bottom are the ones that we're going to use. So if I've got 0.05, I scroll all the way to the bottom. So all the way to the bottom, because I don't need degrees of freedom, is 1.645. That's my critical value. That is the z-score. Let me go back up again. That's the z-score for a significance level of 0.05. That's where the 5% of the area gets cut off. Okay, 1.645. Let's write that in there. 1.645, bottom of the normal curve. Critical value, so z critical is 1.645. So if I go up here and relabel, this is, let's see, this would be a z-score of 0. My critical value, 1.645, that's where my rejection region gets cut off. So z is equal to 1.645. Let me grab another color, because now we can tell if this is significant or not. These will get so fast for you. I mean, we're definitely going through all the theory as well. Where's my test value? Here is my test value. My test value is a bigger z-score than the z-score that starts my rejection region. So it lives over here. I mean, even further over, right? I should exaggerate it more, but it's 3.305. 3728 is more than 3 standard deviations from my mean. 5% of the area got cut off by 1.645, which means that we're in the rejection region. Okay, continuing on with our steps. Step number 4, that means we reject. And when I say reject, it's always, do we reject the null hypothesis? We're talking about it being equal to 3262, or do we fail to reject? Okay, so this is my decision. My decision. Reject the null hypothesis. Okay, I land here. I write reject null hypothesis. I land over here. Maybe my z-score was, 1.1 or something. I write fail to reject the null hypothesis. Not a lot of points there for number 4. Number 5 is where it really matters. Number 5 is your conclusion. What does this mean? What does that mean for my 3728, those students that I interviewed? It means that their average is significantly more. Here it is. I define significance in this little tiny region. It's significantly more than what that national report stated. That's what I write in my conclusion. So my conclusion is that the sample mean is significantly more than, what was that, 3262? And you can also say the student senate, I'm out of paper here, but the student senate is correct. Is correct. Okay, in the next video, we're going to do a lot more, well, they take a while. So we're going to do a few more hypothesis tests, so start to finish. This is a really good video to watch a second time because it just has a lot of theory and a lot of vocab in it.